All right, this is week 3 of Vulkan. And what I'd like you to do is come over here to the resource file over here. And the way I kind of set it up for you raw here was that there were 2 SPV files that are in there. Those are actually kind of useless. I just clicked on those or had those in there so we could bring them up quickly and show you that they're in binary and you really can't read them. So I got rid of mine. I don't know, hopefully you can see that. I got rid of those and I'm going to go add some new ones here. So I'm going to say add existing item. And I'm going to go over to the shaders. And let's see, what did I give you guys? I probably gave you a Fong Vert and a Fong Frag. Let's go look at those. And then while I'm at it, I'm going to go ahead and click on example 27 Frag and example 27 Vert. So I'm going to click all 4 of those and add those to the resource file. Let's go take a look at the Vert and the Frag, the 27. Okay. Now what's going on here is I've got this UBO, Uniform Buffer Object, and the Uniform Buffer Object is in the GPU. It's in a, and it's not particular to this particular pipeline. In other words, shader. So it's not particular to this one. I'm just going to be connecting to it. In fact, if I had a whole array hint of pipelines, they could all bind to the same UBO. So that's just going to be one little location out there in memory. Now think about that from the point of view of efficiency. This is going to be crazy efficient, because all the different pipelines can bind into that. But once it's bound and once I'm able to hook onto it, I don't have to do it like we do in OpenGL, where I have to send down the model matrix, the view matrix, and the projection matrix every frame. I only have to update that memory every time something changes in the camera or something changes in the model. That's the only time I need to update it. So really, that'll shut down a lot of the traffic between the CPU and the GPU. Hey, good idea. All right, so we've got that part, and then no way around it. I'm going to have to go grab the incoming vertices, the in position, the in color, and the in texture coordinates. Now, this file, this is actually not even mine. I blatantly stole this out of the Vulkan tutorial, whose link I have on my home on the Vulkan website. So there's a tutorial in there, and that's why it's labeled as tutorial or example number 27, is it's the 27th shader. There's a lot of stuff in there, and we're going to write our own version of this stuff today and see how far we can get in bringing in lights and all that business. So we're going to be modifying it, but I'll need to use this file. This was the drama yesterday in class, was I couldn't show anybody this file and the other file simultaneously because I didn't have a computer. So I had to just do this verbally and say, hey, you guys go do it. Fortunately, Candide got in there and got a couple of windows up and we could kind of go back and forth. But we're going to go look at this one and then compare it with the Fong shader and see if we can blend the two of them together. I'm going to start writing GLSL shader code. We're going to be writing it, but we're going to have to write it in its full glory. Now, what I mean by its full glory is, you see here on line 10, 11, and 12, I had to specify location points. And you say layout location 0, 1, 2. In OpenGL, I didn't have to say that. I would just say, hey, these are incoming, and they just come in, and the OpenGL driver will figure it out because it's so clever. So it'll work out what's going on. The Vulkan driver doesn't exist or barely exists, and so it doesn't know how to do that. So we're going to have to specifically say what they all are, which just adds to our headache, but it makes it a lot cleaner. in the end. So anything we write here can be backtracked into OpenGL. It's just not everything we write in OpenGL can you use in Vulkan. Get the way that works? Now let's go look at the Fong frag and the Fong vert. Let's see here. Now I stole this code directly out of the OpenGL class. And here I've said there's a projection matrix, a model matrix, a view matrix. We even had a normal matrix and a light position and things. There's no layout positions, none of that stuff. Hey, the OpenGL driver took care of that for you. Wow, that was handy. Okay. And then the incoming, we did do a little bit. So I said, hey, the incoming is coming in here and the normals. So we've got a checklist we have to go through today and see if we can get all this stuff kind of figured out, okay? Here we go. So bring up both and let's start doing some surgery. First off, we got to be at version 4.5. And I'm going to want to fire up this extension. This enables me to be able to use separate vertex files and fragment files. If you don't say this, then the GLC compiler given to us by Vulkan will assume that all your shaders are in one file, and that just makes it more messy. I don't like it. So let's put it in here. So grab those couple of lines of code, copy them, and let's go over to the Fong vert and paste it in right up here. Okay, going back to this example here. I want to bind these to the model matrix, the view matrix, and the projection matrix. Let's copy those lines of code and go up to here. And let's go put that in. Now this means you're not going to need this business or this or this. We never even had that. We'll have to figure out some way around that. Now I've got the GLSL extension running on this version of Visual Studio. So I'm getting the little errors here because all this is now all fouled up. We can easily fix that in just a second. Now I'm doing this because I've already shown you guys how to do Fong shading, and I thought it's probably beneficial to go do it again. If you want to hear about it some more, come to class or come to Tuesday's class and whatever, and we'll go over it and over it and over it until you absolutely die. So what I've done here is we're just going to steal from the OpenGL class and not talk about the mathematics of how I did Fong shading so much. It is a cool thing. So if you're interested in graphics, let's go do it some more and practice it a bit. But if you're not into graphics, well, then just steal from your own work from last year. It's not plagiarism to steal from your own code, is it? I don't think so. You know, the thing I really dislike the most about those little bubbles that pop up is that they're not big enough to actually say what the message is. It just says, Russell just said something from Game Engine CPU programming. That's all it says. I just know he says something. Can't tell what he says. If you guys write software this bad, ever, I will hunt you down. I don't know what I'll do to you when I find you, but I will hunt you down. Don't you ever write code that is this stupid to work. The extension, if you go up to here, I think it's the manage extensions or something like that, and you search around there is a GLSL, something like that. I just forgot what it was called. Yeah, Trevor, thank you. GLSL language integration. That's too complicated of a phrase for me to remember. Okay. Well, so far we're doing pretty well. We've got, let's come down here and see if we can figure out some of this stuff here. I don't have a normal matrix. Anybody remember how to do that? There was a way that you could get around not having a normal matrix. Check it out. Now he just saved the day. Look at that. Let's see here. There you go. So take the inverse transpose of the model matrix and away we go. Okay. Modify that just a little bit. There we go. Okay, so let's see here. Down here, view matrix. So you could call it whatever you want, but I called it just model, view, and projection. So down here, how about just the view? And you would say UBO dot, because it belongs to this. This kind of looks like a structure, doesn't it? The way it's laid out here is it's got the three values in there. You're going to give it some name, open curly Q brace, close curly Q brace, followed by the name of the thing. That's very much how old C-style structures worked. Let's see here, UBO dot model. Hey, there you go. And then this would be the projection, the view, and the model. Oops. And it's not projection. I think I just called it PROJ. Yeah, I did. Hey, looky there. I think we've got a working version. Groovy. Let's go over now to the Phong fragment. I'm pushing the envelope now. Let's see if we can do it again. All right. And I'm going to compare it to the example 27 frag. Let's see what they got going on. Same business as before. We'll get there. Okay, so I'm going to grab those two lines and go to the fragment here, and let's set that up. Yep. Now this is going to be a bit of a problem here. We got to get this business all right. So let's go back to the vertex and see what's going on there. So Trevor, what do you think? If we're going to output this, we kind of have to say what output location you want to do this to. So we're going to have to do something along these lines. Yeah, something like that. So now I'm going to have to specify it like that. Say I'm going to send this out on location 0, and then I'm going to send this one out on location 1. And then this one out on location 2. And now my favorite part of all things, man. Old dead code, kill it. I love it. Now, I don't know what to do about the light position, but we'll work that one out here in a minute. Just leave it alone. But that's going to be broken too. But now if I take these three guys, copy them, and I'm going to paste them in here. And I always screw this part out when I copy and paste. I forget to convert these to in. I do that quite often. And the only reason I'm copying and pasting, I'm not that lazy. I just got to make sure I get them all in the right sequence. You know, that OpenGL driver is so handy to have, isn't it? I don't have to say, if you do these out of order, it'll compile, it'll run. It won't work, but it'll run. And then you'll go nuts trying to figure out why it doesn't work. Now this next one's going to throw everybody off right here. I got to take the output. This is now the output color for that one particular pixel. So remember, this the fragment shader is drawing all the pixels one by one by one by one, and we have to tell it what channel we're sending this one out on. And whoa, Scotty, don't do that. Okay, just copy this line. Okay. So that'll come out on channel, or whatever you want to call it, location 0, because that's an output. So that we're starting over again. Oh man, there's a lot to this stuff. Now just take your time today. We'll get there. We'll get there. So, Trevor, I don't understand your question. Okay, let's go back to the vertex file here and see what's happening. So up here, I'm going to be bringing in the vertex information, and then we're going to bring in the normal information. Now, one of the things we should probably go check today is to go into the Vulkan renderer and make sure that it is reading in the normals and reading in the vertices and all that. I'm pretty sure that it's reading in the vertices correctly because we have Mario on the screen. But I don't know if it's reading the normals in. So we'll have to go over there and check that it's doing that. Okay. All right. Then once we've taken the inverse transpose of the model matrix, that becomes the normal matrix. And then we're going to take all of the normals and multiply them by the normal matrix. And if you recall, what that's going to do is as Mario rotates, I have to individually rotate Mario's normals, so that the normals rotate at the same way that Mario's vertices are been rotated. Otherwise, everything looks pretty goofy. So we got to do that. But then I need, in order to do the Phong shading, my gosh, this stuff is complicated. Why do I have to teach this, Umer? I don't want to teach this stuff anymore. I'm not smart enough. I don't know what I'm talking about. I don't even know. Can you guys even follow what I'm saying? So you got to take the normal matrix, multiply the normal by the normal matrix. That'll rotate the normals so that they rotate the same way that we're going to be rotating all the vertices. All right. But then, according to the Phong calculations, I have to do some part of the calculation over in the fragment file, which means I got to take the normals and push them forward or push them down the pipeline into the fragment shader. So to do that, I'm going to say that the vertex normal here, which I didn't declare out here because I declared it up here as being an output variable. So I'm going to load it into the output variable, and then it pops out over here in the, or pops into, maybe that's a better phrase, pops into the fragment shader over here as the vertex normal. I can't believe I just said all that. I didn't understand what I just said. I think. You guys are very brave to take a class with me again.
It assumes we have a choice.
No, you don't have. Naeed, I know. I said normal a lot. None of this stuff is normal. This stuff is crazy. Oh, what are we doing here? Exactly. The part that's got me excited right now is I'm looking at the fragment shader, and after making those couple of adjustments, I don't see any little pink underlines anywhere here. So I'm overall, I'm pretty happy. Okay. All right, we got just a little bit more to do here, and then maybe we can start seeing if this thing will even compile, because then now we've got the nightmare of having to compile this stuff. It's not like you just push the button and away we go. Boy, it's going to be a miracle if this works. Of all the people that showed up yesterday to class, I think 2 of them kind of got it working. And then everybody else was just staring at their cell phones going, is it 5:30 yet? Okay. So now we're going to calculate the diffuse color. And do that, and do that, and do that. So this is just plain Phong without any texture. Oh, come on, we can jump right into textures now, can't we? You guys are advanced enough for that. Anybody want me to go slow, or can I just go ahead and go fast? Wow, silence. No one wants to be the first one to blow it. Medium. Go Ty, man. I'm with you. Hey, look, check this out right up here. This is on the example 27. On example 27, I have already bound the texture. And the texture is going to work just like those matrices. In the Vulkan renderer code, I'm just going to declare that that texture is bound. And then anybody can look at it once it's been bound. It just says you're turned on and you're available. So any one of the different pipelines that we make could look at that texture. So we don't have to say anything fancy on our side other than on whatever you want to call it, channel 1, there's texture information. So let's steal that line and we can put it into the vertex into the fragment shader. All right. I'm going to pop up here before I forget and just say save all. Okay. All right, we're looking good. Everybody okay? Yeah, Lucas, there's always these cricket sounds, huh? All right, let's go back here to the Phong vertex shader. And we got to figure out this light position. What are we going to do about that? Okay, so there's a number of ways that we can do this. I'm going to be posting up what this is the foundation for the first assignment. The first assignment is to do pretty much, I think it's the first assignment in OpenGL class, which was to make multiple lights. So make 2 or more lights, and I'll give you lots of options for added points and things. So there's a couple ways we could do it. One would be to go build a secondary uniform buffer object, which is which would be lighting. So you can go build a uniform buffer object that holds the light. The weak way to do that would just to be to put the light position inside the current uniform buffer object. Now, I promise you, the best way to get through Vulkan is to do things in small baby steps. Do not take big steps or it will not work. It's just too easy. There's just too many, what do they call it? In NASA, I think they call it too many points of failure. And so, yeah, it's just this basically the same thing. So you can still, if you, somewhere you probably still have that old assignment. And if you go back and look at it, you can see how you set up loops and things if you had multiple light positions. So we can go up here and put one or more positions in there. But to do that, we're going to have to go take a look at how the uniform buffer object works. So to do that, we're going to have to go over to the Vulkan renderer. You guys ready for a little journey? Umer looks ready. Okay. Holy cool. Oh my goodness. Oh my goodness. Right down there was create uniform buffers. Let's go take a look. Let's go there. Go to definition. Oh, in fact, before I jump over to that, let's just kind of remind you guys of what's going on here. This was the startup sequence to get Vulkan up and running. So you had to go pick your graphics card, turn it into a logical device, start building up some memory for the rendering, set some descriptors, which we really haven't talked about, setting up a pipeline, which we called shaders in the in OpenGL, but they're now going to be called pipelines because the OpenGL kind of lied a bit. Some command pools and things. That was just a set of command buffers, frame buffers that we'll need to do. We're going to generate Mario's pants, his fire outfit or something like that. So that's going to be the texture map down in here. And then we'll load up Mario himself. We should probably go check that out, make sure that he is reading in, that we are reading in the normals and not colors or something goofy that example 27 thought it was. I didn't love example 27, but it was the one on that website. So I thought we'll start there and then modify from there. And so then create some more buffer, And so down here, let's go find now the uniform buffers. That was a quick review of the last 2 weeks. Let's go to the definition. Not much in there, was there? Wow. There's just too much of this stuff. You know which might be an easier way to go about this problem is to come up to here. So this is the Vulkan renderer.h file. You're starting to get to know those words. Good for you. Good for you. Aha. I've got a structure called vertex, and that passes in the position. The color. Oh no, we better look into that before today's over. Okay. And then I'm doing some fancy stuff in here. Let's skip over that for the moment. I know. Horrific, isn't it? I'm never going to get citizenship if I keep spelling color wrong. But here's what I wanted to find. Uniform buffer object. And I've got 4 matrices in here. Please note the order of the matrices. I've got the model, the view, and the projection. I don't care what order you put them in, but whatever order you put them in, it better match up here when they load them up. Because all this is going to do, this is going to sequentially string together 4 mat 4s. So that's going to be 16 floats plus 16 floats plus 16 floats. And they're going to be interpreted as first the model, then the view, and then the projection. I don't care the order you put them in, but it better match here, and it better match, where's the H file? It better match there. So if you don't like them in that order, that's fine. Be sure you're consistent though. And if you don't get them right, it's not going to look right. You're going to ask me, hey, what's wrong with my code? Can you fix it? And I'm going to have to give you the Vulcan answer. No, I don't know how to fix it. You screwed up somewhere. Yeah, but you're the teacher. Too bad. I don't know how to fix it. It's too complicated. Okay. Now I'm going to suggest that what we could do is we could go put the light location in here. What do you think? So what we would need then is to go put a vector in there, and we can load it up. In fact, oh my goodness, I've got an idea. Nahid, what works? Yeah. Okay, so give me a vec4 and put in the, let's see, what did we call it up here in the vertex file? We're going to make this thing a light position. So let me copy that, paste it into here, and let's make, I'll explain later why I want to make it a vec4, but just make it a vec4. And now I can dump this. So I'm not going to need light position anymore. Okay. And then down here, this is going to be part of the uniform buffer object. UBO dot. Okay. Okay. Let's go back to the header file. And light position. Hint. When I'm asking you guys to do multiple lights, you know, you might do that. What do you think? So if you were to put that in, you could put a 2, a 3, a 4. How many lights do you want? You'll notice that in a lot of engines, they have a limit to the number of lights you have. And it's not because there's a hard limit to the number of light sources. It's because you've got to pass light positions and some other information about the lights, and you got to put them in arrays. And those arrays on shader files cannot be variable. There is no way to, well, now that you guys are so smart from engine class, there's no way to malloc memory in the shader, and there's no way to use new to dynamically allocate memory in a shader. So you have to hard code arrays. So you'll find that light sources are always limited somewhere. It can be 128 light sources, which would be overwhelming to any mortal. But and the code would certainly look ugly, wouldn't it? That'd be crazy, man, looping over 128 light sources. But you could. Anyway, that was my hint. You're probably going to want to do something like that. Let's go find out where else this uniform buffer is being used. So how about we go find all references. Oh, so we were kind of in the right spot. You're creating descriptor sets, buffer range, size of that buffer. And here That's where I'm actually going to go create the darn object itself. So uniform buffer object, UBO, right there. Create uniform buffers. The buffer size will be the size of uniform buffer object. Hey, you guys are getting good at size of now that we're in engine class and using that one regularly. Believe it or not, I got it all thought out in my head. I just don't remember how I thought it out. That's my only problem. Very good. How about let's go look up UBO again. Let's go see where that one is used. Let's go find all references for that. Here we got a function called update uniform buffer. And if you recall, this is how I get the information down into the GPU from the CPU. So I had to go map the memory in that staging area, copy the information down using the old C-style memcopy, and then go unmap that memory. Okay. You guys kind of remembering all this? I know, crazy. What else we got here? So we've got a little function down here called set UBO, where I can set the projection, set the view, and set the model. And all I've really done is I've just copied the information into the UBO, and then the update then shoves all that stuff down into the GPU. Nice. And then turn that one axis around because Vulkan hates us and decided to flip the y-axis. All right. Hopefully you guys are still kind of flowing along with me. I hope this isn't too crazy because we are jumping around a lot. Now, the next thing I want to go worry about is we're not going to be able to do lighting without normals. So let's go see if this thing is fired up to do normals correctly. How are you going to do that? Well, let's go back up to here. This is the header file. And I remember up here somewhere seeing this, vertex. And the vertex code took a position, a color. No. I want a normal in there. So let's go try that same trick I've been showing you. Let's go find out where all the references are for this and see what's going on. Boy, look at them all. This is load model that we've come down to. That's around line 900 or something here. Load model. This is the tiny OBJ stuff. Let's go take a look, see what's going on in here. We'll load up the model. Now, for those of you who are in Engine 5 class, I guess you're going to start smiling at all this stuff, right? With all the vectors. Talk about being memory inefficient. These things were crazy. So look at all of these allocations and deallocations that we're going to have to be doing. Umer, in class, we were looking at some crazy stuff of what's going on. We were following the memory and watching. We overloaded the new and delete operators, and we were watching what happens when you try to load up a vector. And loading up vectors requires endless allocations and deallocations. It was nuts, absolutely nuts. But it never gets lost. It's been pretty well debugged. It's just not fast. Okay, so here Yeah, and the strings are really scary. String characters. Trevor, I'm surprised you said that because last year you were busting my butt about strings are better than constant characters. All right. You're a very stubborn man. So take a look at what we've got going here. I've got vertex position and the texture coordinates, but the OBJ format doesn't have colors in it. So what I was required to do to keep it consistent with example 27 from the website was I just sort of hard coded a color in there and then used it each time. What we're going to have to do now is we're going to have to work out how to read the normals in and how to deal with that. Now, the ones who came to class the other day, they didn't get this because I didn't know how to verbally talk about this without an example. But here, maybe you guys can help me figure out how we'll do this because you can see the code. So I've got this position here. I don't know, Garen. I think a few of the people that were getting close had everything but normals working. And so the lighting looked kind of funny. So here's what I'm thinking. I'll bet you that if you took attribute and hit dot after it, check it out. They're in there. There's a lot of stuff, skin weights and all kinds of things that the OBJ format handles. We're just not going to be playing with them right now. So I'm seeing this thing here as the normals. So it's going to have to look something like this. All right, so I know it's going to have to look something like that. Let me get rid of this. And then let's go look at vertex for a second. So if I said vertex dot, I've got color, position, and texture coordinates. I don't have a normal. What are we going to do? So instead of using color, let's change it. Boy, this is... Please, 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 everybody, be careful, okay? Yes, please be careful. And if it doesn't compile, throw it all away, start over. All right. I know this is a lot to remember, but we went through and looked at vertex here quickly over here in the Vulkan renderer.h. So this is around line 60 something. Yep. So let's go do right in here. So we're going to have position, the normal, and texture coordinates. That's all we're going to need. Please be careful. Now back over here. Oh wait, let's come down to here. Right. Come down a little bit more. Remember when I said we had to set the layout location? So the layout location is going to be at binding point 0, but location 0 for the positions. That's the vertices. Then down here for the color, that's going to be at location 1. This is now called normal. Then at binding point 0, location 2 is going to be the texture coordinates. Now we've got one other thing we've got to deal with here. And this won't make a lot of sense right now, but it will later on when we do vertex deduplication. We'll need to have this thing injected, the equal operator, but it's going to need the normal instead of color. Normal and normal. I'm not sure I follow what you mean. What do you mean? We're not normalizing anything. The no, I'll bet you it's a vec3. No, wait, no, I think it's a vec3. Okay. Yes, well, we can normalize them, but the stuff I'm doing up in here, this is not normalizing anything. This is setting out where we're going to store all this stuff on the GPU so that I can get it back a bit later. You know, when we're actually doing the render pass, I'll need to be able to find out that I'm at binding point 0, location 2 for these things, and location 1. So you remember I said it was, let's go back to the shader real quick, take a look. That would be on the vertex file. And here we go. Right up in here, vertex is going to be in location 0 and location 1. Hey, you know what? We forgot about the texture coordinates. We'll have to put the texture coordinates in here next. Boy, this is a lot of work. I promise you, it does get easier. This is one of the more challenging ones. Once we get a template up like this, and we've got one that works with vertices, with texture coordinates, with normals, and all that business. Once we get all this stuff up and running, then we can do all kinds of wild, crazy things, and we'll just use this particular file as a template for everything. And life will turn really easy. It's just the first few weeks of Vulkan that really stink. After a while, it starts to smooth out. Please trust me on this. Okay, so to do. I'll need texture coordinates in here in a bit. Let me not get too sidetracked and come back to here and make sure I'm doing all this stuff right. Okay. By the way, what? Sargis, did I miss something? What IntelliSense am I using? Visual Studios. I'm not sure it's Intelli. For the shaders, I'm using, oh, Trevor, what was it called again? GLSL extensions or something. There you go. GLSL language integration. Okay, I'm still back in the Vulkan renderer.h. Down here again, this stuff here is I'm going to be injecting a hash function into the standard library, and kind of some crazy code in here. We're not ready to deal with it today, but we will have to change that from color to normal. So this is like about line 106 or so, at least on my screen. And I'll explain in great detail how these hashing things are going to work. So let's set that for normal. Okay. So it's going to be operator open close parentheses this thing constant. So it's not going to change anything. And I promise I will never throw an exception inside here. This is some crazy code. Oh my gosh. What have I done to you people? I feel so bad. I don't know what I've done to you. Oh my goodness. Okay, I think that's all the surgery we have to do. I could never be a doctor. I'm a nervous wreck. Just helping you do this, and I'm a nervous wreck. Can you imagine me being a surgeon? Oh my goodness. Oh my God. Whew. Okay, let's just do a little bit more. And I've got a proposal for you guys. I don't know about you, but this is making me nervous. So we've been at it now for about an hour. Let's take a break. Maybe we can even take a second break today. But let's go finish this. A little bit more of surgery on this thing, and then we can go sit down and take a break for a minute, cool off, and I can go to the washroom, which is becoming critical here, and I can focus better. What do you do if you're a surgeon and you got to go to the washroom in the middle of surgery? What do you do? Say, oh, it's open heart surgery. Sorry, hang on, I'll be back. Don't forget to wash. I never thought of that. Oh, I'm going to have to go ask my doctor friends. Yeah, hold it. Hurry, hurry, hurry. Finish that. Seal that up. Put his brain back in. Quick. Oh, gross. A pee bag. You just go in your diapers. Oh, man. Humans are gross. They're just awful. All right, let's go back to the CPP file and take a look in here. Clearly, I can't just deal with this. We're going to have to get rid of the color. So that's going to have to be normal. This is no way to deal with it. Okay. So we're going to need to set up a temporary little thing like this. In fact, do you read how I'm doing this? Can you guys read this properly? I'm going to make a vertex. Okay, that's a structure. We were just modifying that. And here I declare lowercase vertex. That's the object. So this is a stack object. The stack object is followed by the open close curlicue brace, which means zero everything out, make sure everything's clean. All right. And I'm just doing that because Vulkan is finicky. I can't make any mistakes in here. Now, part of that vertex is a position. So that's a position vector. Now, the way TinyObj works is TinyObj is bringing in the position as an attribute, and they don't have vectors inside of it. What the author of TinyObj does is just create an array. So, so it goes XYZ, XYZ, XYZ. And what we have to do is we have to go indexing through it. So that would be the X coordinate, that would be the Y coordinate, and then this would be the Z coordinate. Gosh, my voice is crapping out. I think we really do need to go take a break here in a second. So now look at the texture coordinate is just it's going to be a vec2. And so here, this is going to be the X coordinate. That's going to be the Y coordinate. Do you kind of see how that's working? And in fact, I had to go do a little magic in here with some algebra to get that to be the correct one. So I have to say it's 2 times the texture coordinate index plus 0, and then 1 minus the attribute, oh man, plus 1, just to get the alignment right. Oh, the amount of work I do for you guys is killing me. That took me some time to get that one right. Don't break it. Okay, let's do this. We're going to copy this code. So I'm copying the vertex position. Come right down to here and say paste. And this is going to be normal. And then we tested it a little while ago. I can write ATT attribute dot, and he does have normals. And in here, TinyOBJ's author calls them normals. So we got to make sure we spell that one correctly. So these are going to be the same thing in here, except these are going to be normals. Okay, and then copy that. Let's do it again. Here and here. And now we can just get rid of this. Woo-wee. What's the odds that this is going to work? No idea. Okay, Scott's going to go take a break. Okay, part 2 of week 3. And we're doing some brain surgery on this code. And during the break, I just now discovered I've got a little bug in here. And down here on about line 929, where I'm going to load up the vertex. Loading the vertex. And the vertex will contain a normal. And in here, though, I'm incrementing through the index, the vertex index. And what I really need to do is to go in here and go normal index. So we'll need to copy and paste that one. Okay. Okay. I think we're looking good. Is everybody all right? Lucas, are you okay? Did you get it figured out? Okay. We'll go back to the shader in just a minute. We still have some more work to do back on the shader. Okay. Tanner, is it still looking bad? Okay, let's go take care of Lucas's problem here. Let's go back to the Phong vertex shader. And let's go figure this business out now. So what's it upset about here? It says implicit cast from vec4 to a vec3. Well, who all are the vec4s? This guy here, the incoming vertex, is a vec4. So there's a couple ways we can deal with that. One would be I can just convert that back down to a vec3. You want to do that? We could claim that this one is a vec3 and that this one's a vec3. All right. But then we need to modify some of this stuff then. The other way to do that would have been to leave these guys as vec4s if you want. And then wherever that other error was, we can go modify that in a minute. So we could formally downcast it. That's all it was saying, is it won't do it implicitly. We'll have to take it and do it manually. Let me go hit a save. First thing, though, I want to take care of is I also want to take care of the texture coordinate before I forget what I'm doing. You guys still out there? Russell's still there. Okay, cool. All right. Lucas, I'm not even convinced you're real anyway. I'm pretty sure you're just a artificial intelligence computer talking to me that makes me crazy. Let's go bring the UV coordinates in now. So I'm going to type in here layout. Space location equals 2, and these will be incoming. They're going to be a vec 2, and these are the incoming texture coordinates. How about we make coordinates? How's that? All right, we got that. We got that. Let's go figure out some of these errors down here and get this thing running. You know, it just dawned on me that we've got one other thing we're going to have to take care of here. We are going to need to get rid of, let's see here. We're going to have to take care of this. Layout. And I'm going to need to pass forward the, let's see here. That's going to have to be the vertex normal. Where's the vertex normal? Here. We're passing that one out. Good. And then we're also going to need to pass out the texture coordinates here. So let's go layout. And this time location is going to be equal to 4. L-O-C-A-T-I-O-N. Location equals, sorry, not 4. Location 3. And let's output the vec2. Oops, lowercase. We are in GLSL. So it's passing out that, and we'll call it something like how about something like that. So we're going to be reading in the texture coordinates right in here as part of the attributes. We'll be reading them in, but I don't need them in the vertex shader. I'm going to need them in the fragment shader. So we're going to have to pass them forward or pass them down the pipeline down into the next stage, which will be the fragment stage. So to do that, I'm going to create an output variable to send it, because you are not allowed to forward an incoming attribute. You'll have to put it into a secondary one. So I'm just going to call it this is sort of the fragment version of the texture coordinates. Then right down here, I'll make the assignment that the texture coordinates, oops, don't get carried away, go slow, that the fragment, oops, frick, I hate Microsoft. There we go. Frag text coordinates are going to be equal to just the plain texture coordinates. All right, that takes care of that line. Okay. Now, if I'm bringing these guys in as a vec 4 or 3, how did we bring them in? If these guys are coming in as vec 3s, now how would you guys like to do this? We can bring these guys in as vec 4s. So I can bring this one in. Now the data is going to be transferred as a vec 4 whether you like it or not. So we can set them. Yeah, we can set these guys to be vec 4s like so. And if we do that, then you got to kind of knock it down, because the normal now is going to be a vec 4. And then the normal matrix, though, over here is a that's a matrix 3. So if you're going to multiply a matrix 3, you're going to have to take the matrix 3 times a vec 3. So we'll have to knock this guy to a vec 3. Now I did that in the old days with a swizzle. And now the problem there is I'm now passing it back out as a vec 4. Oh, good gracious. So we can do it. Now all the transfers are going on as vec4s whether you like it or not. So I guess we could just bump this guy back up. If we're going to pass this out as a vec4, then this guy has to be a vec4. Or we can pass it as a vector 3. Which do you prefer? Ty, you're in charge. So if we make that a vec3, we're in good shape. Okay. So I made that one a vec3. You know what? The light direction could be a vec3 as well. It doesn't really have to be a vec4. The I direction has to be a vec3. Could be a vec4. Fragment coordinates definitely got to be a vec2. They're just UV coordinates. And so what's up down here? So what we've got here is an implicit cast from a vec4 to a vec3. So who's who? The light position here coming in the UBO, that is a vec4. And what's the vertex position here? The vert position here is a vec3. And that's a vec4. So we can typecast that guy down one. Yep. This is tricky business, isn't it? So we can go dot XYZ. And that'll take care of it. So I can swizzle it down. Or you could typecast it down. So you could also write vec3 here as so, and downcast it. That'll work as well. Keep it slow. How your brain's doing? Okay. Hang in there, Lucas. Put a bag of ice on your head. Yep, I don't care at all. You do it whatever way you can make this thing work. All right, now let's go take a look at the let's see at the fragment one more time and make sure that that's all making some sense. Let's see, where's the frag? There it is. So let's go look at that. Whoops, forgot one. I got to go get this guy put in. Slow and steady, Scotty. Slow and steady. We'll get there. We got to bring these guys in. Okay, so that's the UV coordinates coming in. Go to here, here. Paste that one in. That's coming in on 0.3. Okay, and then that has to be an input, not an output. All right, and that one's still good. The uniform binding of the texture, that one looks good. Okay. I love it. Garen and Nahid are really going for it here, trying to get this thing figured out. I'm not sure. Maybe after class we could all get the microphones on and see if we can get this talked out and get it all figured out. All right. So far in the Fong shader here, I'm not even using the texture, although I brought it in. So I'm going to suggest that we type in a line like this. Let's see here. Let's go right to here, and that's the texture sampler there. Okay, and then we're bringing in the frag coordinates here. So how about a line like this? Now this one cannot be constant, so I'm going to write a vec4 here. Vec4, and let's see here. Let's call it K for color. This is the color of the texture, equals, use the built-in command called texture. Okay. Then we need to pass it the sampler, the name of the sampler, followed by its UV coordinate. And there's its UV coordinate. Okay. Now I'm going to do something kind of crazy here. This may not look as pretty as it could, but it should work. K texture. So down here I'm going to color it with the ambient color. This is going to be the diffuse value based on the dot product and all that stuff that we talked about in OpenGL class, times the KD. That's going to be the color of the light. And then also multiply that by the color of Mario. So that's going to look a little washed out when we do it, but we'll get that squared away later. Okay, that's just because this value up here is going to be too big, but at least I'll pretty much know what I'm talking about. Alrighty, and then we'll do the specular times the K, whatever the K specular was. Okay, so this right here, this is Dr. Fong. Okay. Okay, everybody still with me? This is a crazy day, man. Uh-oh. Brian, you're with me, huh? Everybody else is just got ice bags on their head. How you doing, Lucas? Yeah, of course. Okay. Up here where it says Fong Frag, I see a little star up there. The little star means that we've modified it but haven't saved it yet. So be sure you save it. And I can't emphasize that one enough. In fact, I like oftentimes to come up here to File, and when I'm messing around with the shaders, I come down here and just say Save All, save everything. Now the reason we have to do that, okay. How about the rest of you? Can you guys see my text clear enough? Okay. Let me get back to what I was just saying here. We still have to compile this thing and see if these files will compile. And if you don't save them up here, then the file, because we have to manually compile these things, and I don't think we've even tried that yet in this class. I think we messed around with it a little bit last time and failed to break anything, but now we're actually going to go try to compile these guys. So if you're ready, let's go give it a try. So we've got Fong Vert and Fong Frag. Let's go give that a go. So I'm going to come down here and find my drive here. Here we go. And you guys are fall 2000 whatever. I'm in part 2 today. Let's go to component framework. Let's go down to shaders. Okay. And let's see here. There's the Fong Frag and the Fong Vert. And the way I'll do that is just grab it and drop it on. Hey, compiling all of this business, .vert, created the SPV file, fong.vert.spv, press any key to continue. It worked. I can't believe it. Fong fragment, go grab that. In the entire history of Vulkan, this has never happened. Both files for me compiled first shot. Wow. Hit any key to continue. You know what you cannot do? You cannot grab 2 files and drop them on there at one time unless you want to rewrite that batch file to handle more than one. Candide, what do you mean you can't see anything? Tanner, did that work for you? Okay. You betcha, Lucas. Let me get this out of the way. And now, what code would you like to see? Okay, here's the Fong fragment shader. There's the top. And now the bottom of it. Candide, what's the problem with your shader? Which one, the fragment? That's the end of it. That's all there is. Okay, go up to the top of that. The problem there is that you've got light direction because you were in class yesterday. You put it down as light direction square bracket 2. Yeah, that's the only file I had yesterday when we were screwed up. And so again, I thank you for helping bail me out yesterday. That was very good of you. That made me so upset. So you kind of got a head start, and maybe we'll do that here in a little bit. If this thing up and runs the first shot, and we don't have to do too much debugging, I'll show you how to finish the assignment off. How's that? Or how to get closer to it. And of course, Danny, let's go take a look at the vertex file now. And Lucas will say, "Hey, can you do it from the top?" There it is. There's the top of it. Oh no, you don't see me? Can you see my face now? And you don't see my screen? Okay. Man, what's going on today? Okay. Danny, is this the part you want to look at, or do you want to look at another area? Okay, let's go take a look at Maine. That's just down here a bit. And that's the end of it right there. Yeah, please, please. Yeah, now I can hear you. Oh, excellent. Okay, that looks like you're on line, what is that, 25?
Yeah.
And it says vertex position equals typecast vec3 of the view, the model, and the vertex. I can't read the message. It's too small a print. What's it say? What's the error?
The error is wrong operand types no operation star sign exists that takes up about an operand of type 4x4 matrix of mat 4.
Right.
The right operand of type in high PE3 component vector or vec3, or there is no acceptable conversion.
Okay. And that's the V vertex coming in. Okay, take me to the top of your code. And you've got the V vertex coming in as a vec3. Make that a vec4.
Yeah, the error disappeared.
Okay. And now let's go conquer the next one down. And that is the light direction and the light position. So I needed to typecast. Oh no, you did do that. And the vertex position. Oh, what's your vertex position? That is a vec3. A vec3. The light position is a vec3. What's light direction? Is that a vec4 or vec3? Light direction.
Vec3.
Vec3. I've got that as a vec3. That should all work. So put the cursor on that on the error and just read the error out to me.
Error 314, no such field in interface block light position. And error 212 is cannot convert constructor.
On line 12, you spelled light position, L-I-G-H-T, lowercase p. And down below on line 28, you spelled it with a capital P.
Oh my god, okay.
There you go.
Hey.
We're winning. Don't forget to compile it. All right, everybody else good? Okay, cool. Everybody good? All right. Now we got to go figure out how to go use this. Let's see if this will work. Nothing. We just had a little bug. We fixed it. Poor Danny had a bit of a bug. Okay. All right, let's go back to the Vulkan renderer now. And I'm going to go scroll way up here to the top. And come down here to init Vulkan. That's on my code. It's line 123. And in here, we're going to go create the graphics pipeline. Okay. Let's go to the graphics pipeline and see how that's all put together. We're going to go take a look at that again. Go to definition. And here we hard-coded the name of the file in here. You know what you could do? You could probably go up here and put a Trevor's not here, so he won't complain. You can go put a constant character string and we could pass it from the initialization so you don't have to hard code it into here. Your call. What do you want to do? Kendi, what do you think? You want to set this up so it looks a little nicer? So if you don't want to do this, don't. But if you're brave, let's go do it. I'm brave. I'm brave. constant. Let's see here. Constant character star vertex file name, and then constant character star fragment file name. Okay. I'm just doing this in case I need to revert here real quick. I'll throw that away in a minute. And let's go over to here and put in V file name. And then in here, let's go get the fragment file name. Okay, so it's unhappy because the header file, of course, will not have it defined this way. So I'm going to go grab that string here. Slow and careful, gang. Slow and careful. Let's go grab that. Let's go up to the Vulkan renderer.h and see if we can find where that is. There we go. It's going to be right down here. That's going to be the definition. And then we're going to have another bug, which is we're going to need, let's go grab this name here. Slow and steady. Let's go grab that. In fact, I'm going to grab it with the quotes. Copy. And now let's go back to here. Create the graphics pipeline. So paste that in, comma, paste it again, but that'll be the fragment shader. Okay, slow and steady, gang, slow and steady. Now there's going to be one other place I'll have to do this. Okay, and that will be down here. So this call here, if I have to recreate the swap chain, that would occur when the window gets resized. So I have to go rebuild all the memory I've got once I change the size of the window, because of course that changes the size of the frame buffer and the swap chains, and all of that business has to go get rebuilt, which includes having to rebuild the pipeline. So there we go. We can insert it there. Okay. Now I did that little bit of surgery, so I'm going to recompile it and see if Mario's still there. Very good. I know. Can you believe it? I take it that means yours worked, huh? Go, Tyler. At 5, let's see here. Where was that? 529. So I'm just changing the signature of the create graphics pipeline to take two constant character arrays, the vertex file and the fragment file. Did you get it okay? This will just make my life easier later on. So I'm going to pass in those two files. Then we had to go up to the header file and fix the signature up here on the header file. And then there are two locations where you create the pipeline. The original one, which was way up. Let's see here. Nope to what? Absolutely, 196 coming right up. Wow, you sure you meant 196? The header file, there we go. Okay. And then let's see here. Ty wants 199 of the CPP file. Oh, and the .h, and then 241. There we go, 241 here. All right. Okay, everybody good? It's a crazy day, isn't it? Okay, now this one's the recreate swap chain. And then so up here, there's another one right here. This is in the init Vulkan. So recreate the swap chain and init both require that we change the name of the shader. Now back over here, the shader was called FongFrag and FongVert SPV. Let's go see what happens. Oh, wait a second. Wait a second. We're not ready to go yet. We've got one last thing we got to do, and then maybe we'll rock and roll. You ready? Okay, let's go back to render, or sorry, Vulkan renderer, and go way up here to the top. And I added a uniform buffer object, and down here, I said light position. But what does that initialize to? That's important. So now this being Scott's vector math library, when you create a vector like this on a stack, it's automatically going to set the light position to be 0, 0, 0. But would you like to do it properly and do it so that we know that we've done it? Okay, so uniform buffer object. I'm going to go find all references to it. That's where I defined it. That's its definition. And where do we use it? We're going to use it in here, create uniform buffers. That's going to create the memory for it all. But where does this guy get used? So let's go find all references to that. So it was down in here where I set it. So how about we come in here and we'll say, maybe not there, because that's part of the projection. In fact, I'm going to reorganize this just a little bit. X, let's put that up here with the projection. And then down here, UBO dot, and then light position. Okay, now it was probably 0 to begin with, but now I'm just going to make sure I know that you know that I know that we're going to set that for the origin. So we're going to be, the light source will be right at our nose, and we're going to shoot the light towards Mario. Alrighty, let's see if we can get this thing to work now. So we've got that all set up. Now we just got to turn the shaders on and start debugging from there. We'll go find out what we've done wrong next. Okay, so we're way down here now. Let's get way up to the top and do this again. Here we go. And this is going to be Fong Vert. And the Fong fragment. And there are two places you got to do it. You know, I don't like the idea that we have to have two places to do it. We'll have to modify the code to fix that one up this semester. We got to make this look way nicer than it currently is. All right. No way. Mario, you're being lit. Yes, now I'm fully aware that he's a little bit washed out, but Mario is now lit. And the washed out was kind of intentional. What I wanted to make sure was, let's turn this off and go back and take a look at the shader code. So there's the Phong fragment shader down here, and at the very bottom down here I did this. So let's light them up with just the Ka, and then we'll calculate the diffuse coefficient, the Phong diffusion coefficient. We'll multiply that by Kd. Kd up here is the color of the light. Okay. And then the Kt, which was the color of the texture. So I just wanted to make sure that the Kd was working all right and that the Kt was working all right. The Kt was the color of the texture, which we calculated up here at line 17. All right, so I just wanted both of those. So now if I was to take this and knock it down, where it's just Kt times the diffuse coefficient, then all you would need to do is go up here, say save all, over to here, and let's update the Phong fragment shader. So just update the Phong fragment shader, no errors, and run it again. Can you believe we did that much work today and it worked? Slow and steady, my friends. It's the only way we can do Vulkan. But now we can pass it shaders. So we've got this thing set up where I can pass it various shaders and get things to happen. We've got a light position in a uniform buffer object. Are you still up for some more? In fact, you know what? I think we owe it to ourselves to have some fun with it. Let's just have some fun for a few minutes. My gosh, that whole exercise made me tense. So right up here, I've got this is a constant vector 4. This doesn't even have to be constant, by the way. If you don't want to do it as a constant, you don't actually have to. I sometimes just feel the need to always be a teacher, and that'll work just fine. You don't have to do it this way. I just wanted you to know it's in there. Hey, let's make the light source a different color. Why don't we, let's see here, RGB. I like blue. I think blue would be nice today. So how about we make this something like a 3 or a 2. How about a 2? Okay. And we're going to bathe Mario in a nice blue light. Okay, something like that. So I'm going to go change the specular and the diffuse. The ambient will just be 1/10 of whatever the diffuse light is. Okay, we'll do all that. Let's go save it. Save Phong frag, and let's compile the Phong frag again. That's here. Here's the Phong frag, and compile it. No errors. Let's see if Mario turns or is painted in some blue light this time. Yeah, the specular is blue, but remember I turned off the diffuse light color. Let's just go turn the or change that code around a little bit. This is just for fun. I'm just messing about because it's kind of fun to do it. Let's go put in the KD again times KD, and let's save it. Compile it. Oh, this isn't so bad. Now Mario was kind of lit with the blue light. Hey, what happens if I take the texture and turn the texture off? Let's just look at it that way. Just plain Fong. Just plain Fong, nothing else. Okay, no texture. Let's see here, save Fong fragment. Oh, this is excellent. So I'm going to put the texture back in, save it one last time, and then we'll have a working version of it. Then we'll do a little bit more, and then I think we should call it quits for the day. I don't want to take you too far because that's the assignment. But I'll set you up with the assignment because parts of that are not going to be obvious. So let me help you out a little bit. Okay. Now, again, you know what? I'm not doing assignments in this class to, I don't know, to bother you or to make you have to work hard or something like that. You just need to invest some time in playing around with Vulkan and looking at some of these things and not breaking anything. That's our real, trick here. So the assignments, I hope, will be very, very simple. So let me save the Fong frag. I've modified it. Let's do it one last time. And then we can get on to the next part of the assignment. Okay, that looks good. And let's go run them. I expect to see Mario with his pants on with some blue light around. There you go. All right, everybody happy? Whew, I can't believe we got through that. That is neat. Yeah, so the assignment is to go do multiple lights. Well, 2 lights. Multiple is cool, but you can just set it up to be 2. And then I'll give you lots of extra points for the little tidbits. I'll type that up this afternoon. I just wanted to make sure we could get through this part here. This is what makes me nervous, is doing this live coding stuff, especially in Vulkan. Okay. Whew. All right. Let's go back here and find the uniform buffer object. We just had it there. Let's go find the definition of that thing. That was way up here near the top someplace. There it is. Okay. So Lucas, I'm going to help you out. Now pay attention to all this because I'm going to help you guys make this thing into multiple lights. But I'm going to need Candid's help with this. Candide, you got to help me out, buddy. How many lights do you want maximum? Now, don't make it some stupid number that's going to make our life miserable. You can say 2 or 3 or something. You want to do 2 or you want to do maybe 3? And what's the question mark at the end? Just tell me. 4, says Sargis. And Lucas has got 3 with a question mark. 3, why not? Fine, 3. I'm going to come over here to the structure uniform buffer object, and let's go make it 3 long. Now all we got to do now is not break the code. Okay, so let's go modify everything that we'll need to modify and just not break anything. Oh boy, here we go. You ready? And as soon as we get this to work, I'm only going to make 1 light turn on, but we have the capacity to make 3 light sources. Fine. And so all I'm going to do for the rest of today is we'll see if we can maintain the 1 light source going with a set of maximum of 3 light positions. So here we go. And the reason I'm just going to show you the syntax that's going to be required to do these sort of things. There's a couple of spooky kind of looking calls we're going to have to make. Now what we're doing is for the first part of this is going to be very much Vulkan, but it won't be too complicated. Now, as far as the GLSL stuff goes, you guys should have been able to do that in OpenGL class. So you can go back and look at how you did it in the OpenGL class. I'll hint to it a little bit today, and then we'll be done, okay? All right, so I've got the buffer uniform, the uniform buffer object. It's got 3 different light positions. All right, and then let's see here. Down in here, that's not going to compile. So we would have to say light position 0. Okay, so I'm going to set that to be 0, 0, 0. In fact, you want to muck around a little bit with it? What if we did this? How about we make this guy over here not 0? Let's go shift it over to the left a little bit. So what numbers would you change? This is the light position. Think about it. X, Y, Z. This is going to be the position of the light in absolute world coordinates. So if I want to move it to the left or to the right, you'd modify the X coordinate. So you want to move it maybe 3 units over to the X. So that would be 3 units on the positive X side. Okay. Now down here, this thing here is saying, hey, let's go find out what the, we're on a current image. This is the current frame that we're on. And I'm going to go load all that information down to the UBO. I got the size of the UBO. We're going to pass in the data to it. Now up here, the rest of these guys are not even turned on. Right? So the light source 1, light source 2 have nothing in it. So they just have rubbish in there. It's just going to be garbage. So you might want to initialize those now to some default value. But that's your homework assignment. Uh-oh. Russell, why don't you bring it on now before I get lost? Russell, do you still have a bug? Didn't hear what properly. Oh, okay. Yeah, here's somebody's mic working.
Is it mine that you can hear?
Yeah.
I don't. Yeah, Microsoft Teams is kind of weird. How would I share my screen?
There should be a button up on the very top of Teams. See where the big red button is that says leave? Just to the left of that, there's a button in there that says share.
Open share tray.
Yeah, and then if you hit share, it'll...
So you said the top. big red button.
Do you see the big red button that says leave?
My big red button's in the middle of the screen, next to show participants and hide conversation.
Oh, wow.
Yeah.
I hate Teams. This so sucks.
I don't. Yeah. Trying to see this like.
I'm not saying that I loved Blackboard all the much more, but at least we all knew how to work it.
This is on the app. Raise hand, more actions, so device, so gallery, turn on, start recording, and share.
Do you see what Danny posted?
Yeah, camera, mic, share. Is it because I'm not using the app? I'm using desktop instead.
Oh gosh, yeah, probably. There
Yeah.
you go.
Uh,
Yeah, Tanner, it's up to you. If you want to take off, that's fine. I'm going to show everybody how to do some things with arrays on the GLSL side. So we've got 3 light positions possible.
I'm gonna install it, and then I'll let you carry on, and then I'll
Okay.
be back when it's working.
How's that? Okay, cool. That'll be great. So down in here, the update uniform buffer is going to go right to the size of and load all that memory down in here. Yep. So how about if I just hurry up and jump to it, and then we'll be done for the day, Tanner, and you can get out of here. Okay. Okay. All right, so we made that one little modification there, and now we have the possibility of 3 of those things. So this uniform buffer object idea is really good. Now let's just go see how that would apply over here in the shaders, and then we can be done for the day. So let's go find. Let's see here. Where is he? Fong, Vert, and Fong, Frag, and all these guys. Okie doke. Okay. Now, Tanner, this is why I wanted you to stick around. Check this out. Let's say we're going to bring in all 3 of them. Okay. If we're going to bring in all 3, that's going to die. And the reason it's going to die is that right here, I've said that this is at location 1. But then because that's an array of 3, that's going to be location 1 for light direction 0. And then light direction 1 is going to be 2. And then the next one's going to be 3. So now this one will have to be 4, and that one will have to be 5. You follow that? So when you bring in arrays, this isn't real obvious. When you bring in the array, it starts at location 1, but it's internally going to they're in sequence. So it's going to be, it's not even interpreted. This has got nothing to do with the driver. This is just the layout of the memory. So it's going to be location 1 is the first one. Location 2 is the second one. Location 3 is going to be the third one. And then we can jump to location 4, which will now be the I direction. Now, what a lot of folks do to keep their lives simpler, and that you can take this whole layout here and put this guy at the bottom of this list. I'm purposely not doing that because I want you to remember what that's all about. But I've seen a lot of folks where they put it down here, put it at the bottom, and then just don't worry about it. And the problem with that is that you don't worry about it. You don't spend any time thinking about it. Yep. That's just the way it all works. Okay. Now, if I'm going to make this modification here, that's going to go to 4 and 5. I got to do the same thing in the fragment shader. Right up here. So this is going to be light direction square bracket 3. Okay. And so that's going to have to be in location 4, and that one's going to have to be in location 5. Okay. All right, so now that's going to have to be, that's your light direction. So that's going to have to be light direction, square bracket 0, light direction, square bracket 0. And so for the assignment, you guys just put this thing into a loop here, or whatever you want. So this isn't too bad. Okay, let's go back to the vertex shader and make sure that all looks right. Nope. So we'll need to go square bracket 0 in there. Okay. Oh, that's light direction. That's not light position. My boo-boo. So we're going to need to go, let's see, where's light position? There it is, light position. And light position is going to be square bracket 3. Okay. And that's going to have to be light position 0. Is that right? Nope, that's not right either. Sorry, my mistake. I'm getting tired. Vertex position, light position. That's going to be light position 0 now, right? Not light direction. Oh, now I've got myself all lost. Let's see here. Light direction is going to be equal to that. UBO light position. Yeah, so that does have to be square bracket 0. What line's that? Light direction. Light direction. You know what? Light direction. Light direction. Light direction. That's going to be 3. Oh my goodness. Okay. There you go. Light position 3. Light direction. Got that. We got that. We got that. Okay, let's go save everything. That's here. Save all. And let's go compile it. Let's see how that works. So there's the Fong frag. There's the Fong vert. And let's see if Mario still works. Son of a gun, Mario still works. Oh, Oscar, did I screw that up? So I've got light direction 1. So light direction 0 is going to be at location 1. Then 1 will be at location 2. Next one will be 3. No. Because if it says 3, it's only 4 values. It says 3. It's not 4 values. There's only 3 of them. So it's going to be light direction, square bracket 0, light direction, square bracket 1, light direction, square bracket 2. So there's only going to be three characters. So it's going to go 1. That's the first one. 2. And then 3. I think it's working. Let me show you one last thing for today, and then we're out of here, okay? And that's just, I'm just doing this to help your world, help make everything work better. Let me take you over to this one last thing here, and let's see. Let's go to the fragment shader, because this next part is not going to be obvious. How do you go about making an array of these guys in here, like KD here? How would you go along and make these things an array and not get too lost? So let's say I'm going to make it KD square bracket 3. How would you go about initializing that? And that's really not obvious. So that's why I just wanted to show it to you. So the way you would have to set that up, in fact, let's do it this way. Let's just do 2 of them. Okay. And so what I want to do here is no, we'll do 3. What the heck? You need to say open curly Q brace, and then vec for all of this business, comma, do it again, comma, do it again, close curly Q brace. Let's see, did I get that right? Yeah. And then we'll set that to be KD square bracket 0. And we're not using the KD down here anymore. So the syntax is just a little fouled up here. You got to do open curly Q brace and then put the 3 vectors into there, and then with the closed curly Q brace. Okay. So now I guess you should be armed and dangerous, ready to go. Has everybody got it working? Okay. Let me say save. Save all. And that was the fragment shader I was mucking with. Let's go to the Fong fragment, compile it. Hey, good for you, Russell. And let's go run the program one more time. And I still didn't break Mario. Right there, Lucas. Uh-oh. So Candide, if it's not working, then you need to back up a little bit of what you've done and do it very, very carefully. Back up from where you were. Well, I just did line 15. You probably would want to make a specular component for KS. You probably want KA to be 3 of them. Okay, you only need 1 texture. Okay, I'm just showing you the syntax, Lucas. I'm not doing your homework. I'm just showing you the syntax, because pre-initializing these variables is just not real obvious. Not everyone thinks of putting them in open, close curly Q braces. Everybody got it? Okay, Russell, what's the story? How's your code? Can you find that share screen thing yet?
Hello?
Hey, I think you're
Yeah.
working. Okay, so before you answer that, let me just shut the recording off. Okay, we're done for today.